This model distinguishes different modules, different specific modules that are in charge of each of these steps in the analysis of language, from, for instance, the tokenization or lexical and morphological analysis, or the analysis of the grammatical model of the sentence. There is an underlying modular organization of these components, and there is a very clear division between the processes that take part in this flow of, in this connection between the different modules, and the sources of information that are used by these processes. Here is a graphical representation beginning from the upper left corner of the picture. There can be isolated the speech analysis phase of the communication. If this communication is going to be from speech to speech in a spoken dialogue system, the next step is the morphological and lexical analysis, the tokenization, analysis of the words, the level of the words. The next level is the parsing, the grammatical or syntactical analysis of the set of words obtained during the morphological and lexical analysis. Over the result of the parsing component, the contextual reasoning is able to incorporate a model of about the semantic of the language, taking into account, for instance, the history of the dialogue. If we're working on a dialogue system, we have to take into account not just the current sentence that we have received just now, but perhaps the previous sentences in the history of the dialogue. Then we can apply different techniques in order to obtain some reasoning about the information that we have received and prepare the system to reply to the user. We have in this line from left to right, we are trying to analyze and understand the sentence given by the user. And from right to left now, the system is trying to organize and generate the reply that the system will give to the user. And in this case, the next step should be asynchronous planning, some kind of organization of the reply that the system should give to the user. The next step should be the reversal to that of parsing. In this case, is how from the utterance model of the reply, how can we organize this as a specific syntactical realization in the target language. From this model, from this grammatical model, we have to obtain the morphological realization. How can we create the specific word? How can we select from the lexicon, from the computational lexicon, the words that have to be generated to the user? And finally, again, if we are working on a spoken scenario, we have to incorporate a speech synthesis mechanism in order to transform the written reply to a spoken reply to the user. All along this strategy, this model of analysis, we have different sources of information. For instance, the phonological information, the phonological models that incorporate information about the pronunciation of the sounds in the language, both for the point of view of the speech analysis and the speech synthesis. The morphological information is the global lexicon or the domain-dependent lexicons for the application. Related with the syntax, we need the lexicon, the part of a speech relationships between the words and their grammatical categories, and also the grammar model. At the semantic level, we have to take into account model for the discourse content. Also, from a more general point of view related to artificial intelligence, we have to, if we are going to incorporate reasoning about this knowledge, we have to incorporate also some domain knowledge. And as I have said previously, sometimes we need also to define the general world knowledge. I remember a real case using a system in which we formalized the behavior of the system and we didn't obtain the expected result. And the question was that the system didn't have the symmetrical rule, what should be called in mathematics. I mean, if for some actions there is a reflective behavior, in order there is a symmetrical relationship, or obtain a transitive model, but this notion will not be previously formalized in the system, so the result was completely unpredictable in this scenario. We had to incorporate this kind of relationship in the system, and we didn't expect this problem to appear, but because it's quite natural for us to know what relationships are symmetrical and what are not. But this is not part of the knowledge of the system in itself. You have to explicitly incorporate that information to the system. Well, there is another interesting architecture that was being developed using a big project in the United States. It was called the DARPA Galaxy Communicator Architecture. This is a common framework for dialogue systems that promotes interoperability. In fact, it's not an architecture, but a framework, as it is explicitly stated. The goal was how to build dialogue system and to facilitate the interchange of different components at any time. For instance, if we are working in morphology, how can we use our module for morphology in a different scenario? And what happens if we change this module exclusively? So in this case, it's a centralized architecture which consists of a central hub process which connects with any number of servers, and each server is specialized in the specific human language abilities, speech recognition, natural language parsing, dialogue management, and so on. The hub has 3 major functions. The first one is routing, transferring information or messages between servers. It's a kind of centralized model which allows the transmission of information between any service in the architecture. Also, the hub is in charge of what is called the state maintenance. This implies to store a global information state and to allow the rest of the components, the rest of the servers, to connect to that stored information in order to obtain information and to modify this information. And also the hub is in charge of the flow control of information. This is the classical picture of this architecture, in which we can see this centralized server, the hub, which connects all the different servers. This is a kind of competitive model of language in which at any time any process or any component, any server can collaborate in order to achieve the final goal of analyzing the language. So it's possible. There's no strong sequence or sequential model for the analysis of language. And we have no more time. Okay.